Welcome to our class. Today we continue with our lesson on Noir. This time we'll be writing zero knowledge proofs in Noir. So I'll be taking you through a way of writing zero knowledge proofs. In our last lesson, we saw how to install Noir and how to write some circuits in Noir. Part of our today's lesson would recap what we did in our last lesson, but more specifically focus on how do we write zero knowledge proofs, how do we, for instance, verify the proof or generate the proof first of all. How do we generate the proof? And after generating, how do we verify the proof? And so all those steps up to verification of the proof. And even we have generation of the key and so on. So all those steps are what I'll be taking you through in our today's lesson. And it will be hands-on. So at some point, I'll then share the code and show you. We will write a code, some simple code, and see how to go about generating the proof and verifying that proof. But before that, since we are supposed to be looking at zero knowledge proofs, in Noir, we first of all need to know what a zero knowledge proof is. And I've just written here the definition, just as a reminder, because I know we already know what it is. So I say the zero knowledge proof would allow a prover to convince a verifier that a statement is true without revealing any additional information about the statement. So for instance, the prover wants to convince the verifier that he knows what X is. So that is what the prover will be doing. And at the end of that process, the verifier would not get to know what X is. So there's no information about X being revealed to the verifier. But the verifier at the end of the process is supposed to be convinced that the prover knows what X is. So that is the only thing that will be happening. So an example is where the prover wants to convince the verifier that he knows a password and he doesn't want to reveal the password itself. That's just an example of a zero knowledge proof. Now, so under this, we have a few terms that are critical. One is witness. Witness will be the secret input that is only known to the prover and the verifier does not know what it is. In this case, it would be that password. The password is known to the prover, but the verifier does not know what the password is. And at the end of the process, verification, as the prover tries to convince the verifier, the verifier should not get to know any information about the password. And the other keyword is public input. Now, this public input should be known to both. They'll be known to both the prover and the verifier. But the witness would only be known to the prover, not the verifier. And then after that, we also have the proof itself. And the proof will just be a cryptographic evidence that the secret satisfies the public relation. So these are what we'll be doing. So we'll be writing some ZKP in Noir, and then try to generate the proof. Then after generating the proof, we would try to then verify. So I'll be taking through those steps. So the good thing, in our last lesson, we looked at how to install Noir. And so after installing Noir, we also looked at how to write some circuits. And so today, then we proceed and see how to write zero knowledge proofs in Noir. Okay, so Lynette, how are you?
I'm fine.
Okay. Had you installed Noir?
No, I had not.
You had not, okay. And I also think even Nelly had not. Nelly, what about you?
I had already installed Noir.
So you have it.
Yeah, I have it.
Okay, okay. Now, there are various ways of installing it. I don't know the one. But we will try and see whether yours works. And so during this lesson, to explain how to write some of these codes, because what I want is, I want to take you through how to write zero knowledge proof, how to generate the proof, how to verify the proof, and so on. So through all those steps. So I don't know whether you're able to open. Did you use WSL, or what did you use to install?
Yeah, so I am on a Windows machine, but I use WSL.
What did you say?
Yes, I did use WSL.
Yes. Okay, okay, okay. Now, so just open the WSL so that I take you through the process of writing some short circuits. You will share your screen. And then after that, after I take you through the steps, I think Lynette, at a later stage, you may want to install it later and just follow the same steps to write zero knowledge proofs, generate the proof and verify, and so on. So that is what we'll be doing today. Nelly, are you able to share your screen?
Let me try. Let
Especially
me
for
just share my
the
screen.
WSL.
Okay, let me see. Let me see.
Okay, okay.
Oh my God, I forgot. So recently I switched to Linux. And I have not
Yes.
installed the Noia on Linux. I was using WSL, but then I switched to Linux yesterday, so I have not installed like everything I had previously on WSL. Oh, I forgot about that. Sorry.
It's okay. Now, therefore, I'll share mine, and then we use mine to for
Yeah, that's
explanation.
perfect. Okay.
Just a few seconds. I open. Now, again, installing Noir, there are so many things after installing Noir. There's several others you need to install. which work, they work together with the Noir. There are several things. If you check my first video, you get to know what else supposed to install so that you are able to run your code properly. Now, so mine is on WSL, so I just want to open WSL. I'm using, you can use WSL, you can also use, is it called command prompt or CMD? I think you know those things. You can use any of them to install.
I can't see a screen.
Yes, I'm now sharing.
Oh, okay.
Good. Now, this is my WSL. This the terminal. You can see where the terminal is. Huh?
Yeah, yeah.
Where? Okay. So if I want to write a code, first of all, I need to specify the directory in which I want that code to be saved. So let me say, for instance, supposing I want it saved in Rust programs, then it means that is the directory that I need to save it in. So I'll cd that directory. I'll cd the directory. So let me say I want to save it in Rust programs. You know, this one, when you write it, it will not be saved on your desktop. It will just be saved inside the program. Inside the, I don't know whether it's inside the WSL or what, but inside there, you'll not be able to see it inside on your desktop or among your documents. It cannot be seen. So I cd where I want to store it. So I want my program to be, my code to be stored inside these Rust programs. Now, then the next thing is, you see, when you install Noir, you have also to install Nago, because we shall be using Nago command. So you say Nago new, then you write the name of the title of your code. Let me, for instance, say I want my code to be called, let me just call it first, or let me call it zero knowledge. Zero knowledge. Zero knowledge, I can say lesson. I can just call it like that. So this is what we want to, how we want it called, and it has said project successfully created. It's located at home /Cyprian /Rust programs, and it's called zero knowledge. So that means now my title has been, no, the project has been created. So the next thing I do is I now want to open it, but first of all, I cd it. Cd what I've just, just a minute. It's not called. It's it's cd. The one we created is zero knowledge lesson. Then now that is how it looks. Now, for me to write my code, I'll then use, you can use Visual Code, Visual Studio, or any other. We have so many ways you can write it. But if I want to use Visual Studio, I will write code and then space, full stop, that, and then if I press enter, it opens the Visual Studio directly. It opens the Visual Studio directly, and that Visual Studio already has the main.nr. It already has the main.nr. So that is what will now be want to change to the code we want. So let me just press enter. Then it will open that one directly. Now we are going to the Visual Studio. So let me now share what has. Let me share this and share what has been opened now from my end. Now you can see the Visual Studio. Can you see what I'm sharing from my side?
Yeah.
You can see it, huh? Now, so
Yes, we can.
So once this one is opened, when you look here, you can see we have the SRC. Under it, you have the main.nr, and the main.nr has some code. So this is what we shall delete and replace it by the code we want. And then we have the Nago Tomil that has the dependencies and so on. But let's just come back here. This is our code. And now we want to test. We will be testing. We see of the main. This is the main. Now, if I remove this part of the test, the main will still work. But the test is just meant to ensure that this main, whatever the main says, the test, this part of the test, this code for the test, this function would be testing whether this one has been achieved, whether this one has been achieved. Now, let me just, before I go to how to write, because we want to write a code, we shall be writing a code later. But before that, let's just want to show you how to run this. We come to the terminal. Come to the terminal there. Now you can see we already have this one here. We have Rust. We are inside Rust programs. Then we have zero knowledge lesson and so on. So if you want to run, you can say Nago compile. Nago compile. And when you say Nago compile, you can see it has added something here. On my left, can you see target? Can you see target on my left, on the left of the screen, where I'm pointing?
Yeah. Yes.
Now inside target, we have this dot JSON. So this is where the witness will be. This is where the witness will be, and you see when I click on it, it gives me the witness, which has been hashed to something and so on. Now, there are so many things that will come here. This is not the only one that will be here. There'll be several, as depending on the command you give it. Depending on the command you give it, there are several things that will then be changing. Now, our Nago Tomil is still the way it was. But we have a new thing, a new file, the target. Under it, we have this .json. When we were writing our SACOM language, we saw Sorry for that. It's internet. Let me just again share. Now, so that is the first command I've looked at, is a nago compile. The other one, we want to test whether the main function is okay. So you can say nago test. And when you say nago test, it tells you that the zero knowledge lesson running one test function, testing the main, and the main has been tested, is okay, and then one test is passed. Now, just before that, let me tell you what this code means. The main says, because you're not there the first lesson, what the main here, X is a member of a field. Now, if we had talked about fields last time, X, 1, 2, 3, and so on, and Y is also a member of a field, but there's a difference here. You can see that Y is a member of a field, but it's public. It's public. That means that the verifier has knowledge of what Y is. The prover also has knowledge of what Y is. By word private, when you don't write, because there's no word public, prover knows what X is. But now Y is known to both the prover and yes.
I got lost you because your voice is breaking. Maybe it's the internet. Could you please repeat that?
Pardon?
I quite lost you because your voice was breaking.
Yes, so I'll just explain.
I didn't quite.
Is that okay? I think there's, I don't know whether, Anthony, can you hear Nelly correctly, clearly? I think she's breaking, and then she disappeared. Nelly, are you still there?
Internet is slow.
Or my internet is
It's a bit slow.
Yeah.
is low. Can you now hear me, Nelly?
Yeah, yes, I can hear you. Please repeat the part you're explaining the public field, the first part.
Yeah, there are things that are private, only the prover needs to know. And there are things that are public, both the prover and the verifier must know. So if it's public, you indicate by the word pub, short form for public. And if it is private, just leave it like that. Like this one, you just say X is a member of a field. You've not specified as public. So, by convention, these are inputs. They can all be public or they can all be public. So if I want to be public, I write their pub. And so if I just say cargo test, it will still run. No, not cargo, it's nago. It will still run. So inputs, they can be both private or they can be both public, or one can be private, another one can be public. The word public, or public from all of them. And so the word pub is just used if you want some input to be public, word public before the word field. Currently, all private. Now, what is this code doing? What the main function is doing, you can see I've written here assert. I've written assert equal to y. X is not equal to y. Now this x public here. Now this x is known to only the prover, verifier, what y is, because it's a public. The test, when x is 1, and y is 2, it's true that x is not equal to y, and therefore it will pass. It will pass because x is not equal to y. But if you make them not pass, because it is, so if at this point I say NAGO test, and then I expect it to fail. So it has failed. The test has failed because what has been written here, because the test is supposed to test the main function. It's supposed to test the main function. So the main function says x is not equal to y. So that is what it must do. That is what the test should be doing. So if I say now 7, x is 7, and y is 2, then it's supposed to pass. That test is supposed to pass. Now I've got test. Now, so I've taken it through 2 commands and what they require. The other command is NAGO execute. NAGO execute. Now this one, you cannot run it before you have to add the prover's toml here. You have to add here prover's toml and put there some elements. For instance, if I run it right now, it will not run because it's expecting that I'm supposed to add some file here at the prover's toml. So let me try to run it the way it is and see what it says. It says cannot find input file. So the input file that is expecting is the prover's toml. So that means before I run NAGO execute, and the NAGO execute is the one that will be giving me the proof, the zero knowledge proof. It's supposed to give me the zero knowledge proof, which I'll then be verifying later on. So before I say NAGO execute, I must provide the code with the prover toml here. So you just come here and then add the prover's toml, prover.toml. Now this one you have to input some values. You have to input some values inside here, which will then be which it will then be looking at whether they are correct. Just like the inputs, just like the inputs we were putting in the JSON, in this JSON. Although the one in the JSON is already hashed, but here now you just put here the exact values that we expect. Now, so these are the steps I'm supposed to, these are very simple proof, any circuit. So I'd wish we write another circuit and then we go through all the steps. Now, so what I'll do, I'll just change the current circuit that we have and then replace it by a different one. But I hope you remember how we reached here. We went to our WSL, then thought of where do we want to store our program with CD. For in our case, we did CD Rust programs. That is where I wanted it to be stored. Now, so let me share another simple circuit, just another simple circuit again for just explanation. Since I want to begin from the scratch, I'll begin by deleting the target because it has something different. So let me just delete it. I can even delete this prove terminal because it has nothing at the moment. Now, so let me change the code. I want to change the code. Let me now write a simple code here. And the simple code here says X is private. You can see that. Y is public. And then we have output. We have output. I did this because I wanted to explain whenever you have an output. In our previous code, there was no output. In our previous code, we were just comparing X and Y, and we were saying that X should not be equal to Y. So there was no output. But in this case, there's an output. Whenever there's an output, the output will always be public. The output will always be public. It can never be private. So the output is supposed to be known to both the prover and the verifier. So for instance, in this case, it is public. So if I say Nago compile, it will accept. But if I make it private, by deleting the word public and say Nago compile, it will not accept because an output is supposed to be known to both the prover and the verifier. Anytime you have an output. So like in this case, we have X plus Y and is giving us, no, X plus 3 is giving us Y. So that means this Y must be public. It must be known to both the prover and, but now the inputs can be private. Like this one can be, let me see if I were to remove that and say Nago compile. Yeah, it accepts. But the thing is, whenever you have an output, like in our case, you can see this arrow is pointing to. So you have the inputs, and then after the inputs, we have the output. The output must always be public. Let me return the public here. Now, so what does this mean? It means the assert. You see, it's always you have the assert, and then you put what your main function is doing. for instance, saying x plus y should give, no, x plus 3 will give us y. Now, if I say NAGO test at this point, it will not accept because I've not put any test. I've not put any test. Yeah, it will accept, but it says 0 tests passed. 0 tests passed, that means there's no test. And then it also says running 0 tests, because I had said NAGO tests, but there's no tests that are included. So that means it has run no test, and therefore no test has been passed. So for me to avoid that, I will now include my test, and the test is there. Look at how the test begins, and we saw it in our previous code. You begin with the hash, and then it tests inside these brackets. Then you are testing the main function. You are testing the main function, and the main function, you are saying that if x is 5, if x is 5, then y must be 8. If x is 5, then y must be 8. So assert result. Assert result. So the result is 8. So when you say NAGO test at this point, when you say NAGO test at this point, it tells you that it was running one test and it has been passed. The test has been passed. Now, if you put here wrong result, x is 5, and you put a wrong result for y, want to put there 7, then it must tell you that that is wrong. Now go test. The result we put is not correct. Even if you have to change this one and make it 7.2. Now go test. It will still fail. Let's make this one 8 and retain the 7 at the bottom. See whether you can trick it. It still fails. So the test has not passed until everything is correct. Now it's now okay. It's now okay. Now, we said we have also a command called NAGO execute. And for us to do that, we have to create the prover toml. So I just right click inside here and say new file and prover toml. Now, so it opens a place for me to put the values for x, the values for y, and the values for the result. So that is what we call witness. So it's opening for us a place to put our witness. So in this case, what do we want x to be? What do we want? Was it x or was it a? So my code has x, y, and y. X and y, let's see. Now, the way we type the NAGO toml, you put them inside curly brackets, So you may want, for instance, say x. There is these quotation marks. I don't know how to write them in using my laptop, the quotation marks. They're supposed to be inside quotation marks, the opening and closing quotation marks. I want to see what I have quotation marks somewhere so that I can then copy and paste, because I can't see where I get them, where I can get them.
You can find it next to a letter, the enter button.
Oh, next to enter.
The left to the enter button here. You just shift. I think not that one. Below those ones now.
Oh, shift.
Yes.
So that one.
Yeah. So if you do two,
Are they the ones I put?
you can get
These ones.
yes.
Okay. So let me say x is 3. Say x is 3. Then comma. Y is let me again put those. Y is 5. Let's try those and see, and say now go execute. Now it says failed to have not put the inputs correctly. Must put them correctly.
I think volume was
terrible. Now, so Lynette, you can still hear me?
Yes, I can.
And Anthony?
yeah, I can hear you.
Yeah, so we had not put, I was supposed to also put some marks here. I think that is what we had left out. Failed, badly formed. What's the problem there? I'm using the correct marks. Okay, let me copy one here. Let me just try and copy the correct one and input there. Just a minute. Just want to copy one that I already have. Those quotations properly written. Normally, this side where I am during this rainy season, the network is normally very poor. That is why you find sometimes I'm locked out. As this is a problem of using a different machine. So I don't know whether when I was writing, I was using a different one. Now, so those are there are several other commands, but this is just one of them. It is supposed to generate a proof for us. Just a minute. Okay, so I cannot see one here that I can copy. That means Okay. I think I was confusing. Noah and what? Circum. So let's write this equal. I remove this. I think I was confusing Noah and Circum, which we just did last time. Let's again run it and see what happens. Now go execute. Ah, same thing. Okay, now the problem is this. The problem, let's go back to, I've used, the problem is, I've used five and three.
My screen.
You cannot hear me?
I can see your screen.
Oh, okay, yes. Let me, yeah, the problem that we have, now where is that? I want to share, I can't see where to share actually. Now, okay, the problem I'm getting is from here. I have five. When you put x to be, in our proof atomic, we put x to be 3. So if x is 3, what happens? Y is supposed to be 6. That's where the problem is. Y is supposed to be 6. So for us, we put y to be 5. Y is supposed to be 6. That's where the problem is. Now go execute. Invalid key. Why is it giving me this? I can't tell why it's giving me a wrong result. top arrow align 2, column 8. Just a minute, maybe why it's not working, because I've tried all options.
Hey guys, I think Pauline is having some internet issues. I don't know. Maybe we can. Do we wait for him like for 10 minutes? See if he's come back. Or then he just joined. We've been going through installing Noir and some few circle equations. Lynette,
Yes.
hey, habari.
Ati?
Hizo lessons zingine you guys mlipitia tu Sacom?
Kuna zenye nilimiss hapo katikati but enye nilijoin ilikuwa ya Sacom.
Nice. Yeah. Itabidi ni catch up. Let me try to reach out to the teacher. Yeah, amesema he's coming back. A few network issues. Me on my end, I've been trying to run some Aztec nodes, but unsuccessfully.
I think we can postpone it and have it another day because I think my network will not allow me. But we can try a bit and see. I can see the time is already gone. So we can we revisit.
No worries. I think we can do another class next time. We'll continue from there. Yeah, I'll just call and inform him. Thanks, guys, for showing up.